we're back for example 10. Again, find each limit. Limit as x approaches infinity. We have 3x minus 2 over the square root of 2x squared plus 1. And over here on number 2 is the same thing, except we're going to negative infinity. So these are limits at infinity. And what we're finding when we evaluate this is either, if it's a finite number, let's say 7, a horizontal asymptote in that case, or if it's unbounded, then that would be, say, the end behavior of that graph, which might be a slant asymptote. These functions, or this function, since it's just one of them, it's not technically a rational function because of the square root that's in the denominator. But you know what? Doesn't even matter. We still start it the same way, which, yeah, you guessed it, a direct substitution. So on this number 1 here, mentally directly substituting in an infinity, 3 times an infinity, infinity minus 2, top, still infinity. On the bottom, 2 times an infinity squared, that's infinity, plus 1 more, still infinity. Really, really big, take the square root, still infinity. So we have our indeterminate form, infinity over infinity. I need to resolve it. So I need to find another function that's going to agree with this one, but help me figure out where that horizontal asymptote is if I have one. And that strategy, just like the strategy before, is to divide the top and the bottom by the highest power of x in the denominator. So you might think that the highest power in the denominator is an x squared, but it is surrounded by a square root. And we just talked about how the square root of x squared is equal to the absolute value of x. However, in this particular case, x is a positive number because I'm going towards positive infinity. Over here, number 2, it's going to be a negative number. But on number 1, it's a positive number, and we talked about how if x is a positive number, the absolute value doesn't do a whole bunch of anything, and it's just x. So for this particular case, since x is positive, that's just equal to x. What that means is we're going to divide the top and the bottom by x. Let's do it. The limit as x approaches infinity, I'm going to have, of course I don't remember it, 3x minus 2 over x over the square root of 2x squared plus 1 over x. The top is going to simplify as we would normally expect it, as we've seen in some of the other examples. This x dividing into both of these, 3x divided by x is just 3, and then negative 2 over x for the second term. So 3 minus 2 over x over. And now what I want to do is I want to actually bring this x into the square root. So what I'm going to do is rewrite that x as, rewrite that thing as the square root of x squared. And again, one more time, since x is a positive number, x and the square root of x are exactly the same thing, okay? So I can rewrite and bring that square root on the inside, and I'll do that here in just a second, plus 1 over the square root of x squared. So we have a property of square roots where you have the quotient of square roots is the same thing as the square root of the quotients. All that simply means is that square root gets to come inside here. Let's rewrite a whole bunch, or maybe copy and paste stuff. And I would have big square root 2x squared plus 1 over x squared. And now I can kind of do this division on the bottom, divide x squared into both of these. So 2x squared divided by x squared is just going to be a 2, and then plus a 1 over x squared. So top staying the same once again. Bottom is now going to be square root of 2 plus 1 over x squared. So we finished all of that simplification. We're going to try this again, direct substitution with that infinity, and see what happens. So when I plug a infinity in here, there's the limit of 2 over x. As x approaches infinity, that part will just go to 0. And so will this piece. But the 3 and the square root of 2 is going to stay. Those will go to 0, and I still am left with 3 over the square root of 2. So what did we just find? Since we found a finite number, we found an actual number that we could count up to, we just found a horizontal asymptote for the graph, right? A horizontal asymptote. Let's look at number 2. on number 2, it's the exact same function. Is anything going to change whenever we approach negative infinity? And the answer is, yeah, it is. And the reason why it is, well, here, let's take a look here. Direct substitution. So I'd have 3 times negative infinity. I'd have negative infinity minus 2, it's negative infinity. Oops. A negative infinity. And then down here on the bottom, when I square that negative infinity, it's positive infinity times 2 plus 1. Take the square root, it should be a positive number. What's a negative divided by a positive? Should be a negative, right? So let's see this thing happen, like play out. How does that affect what we just found right here? When we went and divided by x on the top and the bottom, we used the square root of x squared on the bottom and said that that was equal to x. Well, it's really equal to the absolute value of x, but since our x was a positive number, we could ignore the absolute value signs. This time, the square root of x squared being equal to the absolute value of x, since x is a negative number, let's come back up here. If x is a negative number, that actually is negative x. That'll be equal to a negative x. So keep that thing in mind. Keep that in mind whenever we go to evaluate this particular limit. So on number 2, limit as x approaches negative infinity of, we're going to have this 3x minus 2. We're going to divide that by x, just like we did before. And then the square root of 2x squared plus 1, we'll divide that also by x. So everything right now is still the same. Process is still the same. As a matter of fact, the top is going to still simplify exactly the same way that it did before. The limit as x goes to negative infinity, I would have 3 minus 2 over x, okay? But on the bottom, in order to get this x into the square root, just like we did before, we're going to think of it as the square root of x squared. But since x is a negative number in this case, x is actually negative the square root of x squared. Why is that? Because if I just did the square root, back up here, the square root of x squared, I would always be getting a positive number. But I know that my x is supposed to be a negative number, so I'm going to compensate with that little negative sign that's on the outside of it. That's what I have to do to resolve the little square root, bringing this x into that square root. I don't have to worry about that on the top, though, because here with x by itself, I know that x is a negative number because I'm plugging in something that's approaching negative infinity. But I don't know that whenever I take the square root of x squared because it's always supposed to be a positive number. So in order to get that negative back, I'll have to throw that negative on the outside. Whew, okay, so all that meaning that we're going to divide the square root of x squared plus 1 over negative the square root of x squared. And now I'll use that same property of square roots and I'll bring these things together, and this negative sign is going to remain on the outside of this. So 3 minus 2 over x over, and then, oops, don't forget your negative sign, square root of 2x squared plus 1 over x squared. And again, what's in the square root is going to simplify exactly the same way. The only difference is that I'm going to have that extra negative sign on the outside. Did I not throw a negative on this one? Pretend I did. Minus, I'll just go back in time and edit this. Square root of, and then we'd have a 2 plus 1 over x squared. Okay, so now whenever I do my little direct substitution here with a negative infinity, doesn't matter, this thing is going to go to 0. This one will also go to 0. And we're left with these two numbers up front, this 3 over a negative square root of 2. Negative 3 over the square root of 2. Now, compare that to our previous answer. We have a second horizontal asymptote. So here is an instance where we have a function, and this function is going to spit out two horizontal asymptotes. Let's take a look to see what that looks like. So these little animations here is just reminding you that When your x is positive, x is equal to the positive square root of x squared, but when your x is negative, it's equal to negative square root of x squared. Okay, so here's what the graph of that thing looks like, and you can see that we have two horizontal asymptotes. As we approach a positive infinity over here on the right-hand side, it's going up to whatever that 3 over the square root of 2 is, and down here on the left-hand side, as x approaches negative infinity, we're approaching the negative value of that.